Let's have a look at the new fault injection framework feature of Simics 5 and how it makes it easy to inject faults in a target system as well as to record and later replay a particular fault injection campaign. To start with, we need something to test with, and to do that we pick up a pre-built configuration where we have a very simple memory test program loaded on a bare bones machine. The memory test program is what you see here. It essentially writes alternating patterns of ones and zeros to a memory location, reads them back in and checks if the result match what was written, and if not, we obviously have a memory error. So this is a fairly typical old style way to check if memory has any kind of stuck at 0 or 1 errors. So if we run this program once, you can see that the target system ran, and press a key, you rerun a test, and we have rechecked another few hundred megs of RAM. So next step is let's make the memory fail so that we actually have something detect using the test program. So we start by loading our example fault injector. We list the fault injector we have available, and we decide to create a new sample fault injector for memory, which we call FI. We then take this FI fault injector and attach it to a CPU in the system, since we will be intercepting memory reads and writes, actually writes from this processor to implement the error. At this point in time, we have a fault injector attached to the system. It's time to start injecting faults. And let's record what we do so we can later reproduce it. Okay, let's give it a name, and we're ready to roll. First of all, we start Simics running, and then we reran the test. You can see that the memory is still intact. We can then pause the execution, and we enable an error at some well-chosen location in memory. We set the AND mask to I don't disturb using AND, but we set the OR mask to something like this. This will mean 1 bit is stuck at once. Let's see if that's what we detect. Then we rerun, and sure enough, the memory test program detects an error at the address we used. If we want to see how many errors we hit, well, we take a look at the fault injector, check its status, and we can see that we have hit 2 times, because each test, as we see above, contains of 2 writes. So that makes perfect sense. Let's add another error and see how that plays out. We choose some completely other address, and this time we're gonna use the AND mask to break things. So we rerun and see what happens. And this time, since we had a much bigger error hitting many more bits, we actually see 2 errors detected, both for the 5.5 and the AA pattern at this new location. So that's pretty much it. I mean, we have injected a couple of faults in the target system, rerun the test program. Actually, we can rerun the test program once more just to show that the errors are still there. And if we take a look at the status of the fault injector, which we can do from command as well, we can see that we have hit the first error 6 times and the second error 4 times. So you have statistics about just how often these errors have been activated. So let's quit this run and look at how this looks for the recipient of a recorded error campaign. So assume we now want to show this error injection campaign to a colleague, because the errors we injected managed to make the software behave in some strange way. We then open up this checkpoint container recording, and when we start, we're already some distance into the run, right? We already run the memory test once. So if we start replaying now, we see that we rerun the test once, And then while the target system is standing still, we're busily working in Simics, adding the first error. We rerun the first error, and as we can see, it's the exact same error detection at the exact same address as before. And now I'm adding the second error to the target system, and I will soon rerun the memory test in order to see if that had the intended effect. And we're essentially replaying both the inputs to the target system and the actions on the Simics command line at once, so you can really see what was done to the target system and the effect it had on the software in a completely repeatable and replayable way. I mean, I can pick this up again and again and again and replay the exact same fault injection scenario. So here we saw the run with the second error. And if we go in here and check the status, we can see that the statistics are being updated live as we replay the scenario. And now it stopped because we replayed the entire work we did before. Well, that's it. Thank you very much.